Yeah, hello, my name is Jan Brugard. I'm from Wolfram Math Core, located in Linköping, Sweden. We are responsible for the development of SystemModeler, and today I will present the new features from April this year, as well as, and mostly actually, new features that are coming later this year or beginning next year.
So passing on a bit of Swedish Candy there for those of you that want to taste. It's Swedish. Well, most of it is from Sweden. Everything is bought in Sweden. Some of them are not produced in Sweden. I think the one you have there is Finnish, actually. So in the 50s, 60s, something like that in Sweden, we decided to introduce something called lördagsgodis, Saturday candy. The idea was to focus all candy eating to one day a week to get less consumption of candies, right? And the consequence, of course, was that kids started to demand candy every Saturday and continue to consume just as much candy the other days. So nowadays, we are the country that eats most candy in the world. So yeah, and what does that have to do with this presentation? I'll get back to that. My name is Jan Brugard. I'm the CEO of Wolfram Math Core. We develop SystemModeler, which is one of Wolfram's products. Today, I'm going to focus on what we have done during 2019. In April, we launched SystemModeler 12. Now, the last few weeks, we have launched 3 what we call virtual labs. And then actually, since last conference and until now, we have been working on 12.1 and beyond. Oh, sorry. Let me turn this on. OK. OK, so that's the things I want to cover. And I would say I have material for like 5 presentations in my presentation here. So we'll see what I choose to present and not. I will for sure not present everything. That said, I will focus mostly on what hasn't been released yet. I think that's what this conference is sort of all about. But just a quick summary first of SystemModeler 12. It was released together with Mathematica 12 in April. It focused on 3 areas: model creation, model exchange, and model optimization. And for the sake of time, I won't go through anything of that content. Instead, I would say invite you to come down to the basement, and we can present there, where we have more candy, hopefully, if not everything hasn't been consumed. And also go to the web page where you can see quite a lot of information on what was included. So likewise, the virtual labs. These will be covered in the next talk by Ankit, my colleague Ankit down there. So these are, we are trying to do, develop models or packages with models in SystemModeler together with material that fits into different courses in colleges and high schools. And the idea is to be able to cover sort of the entire engineering curriculum and make teaching come more alive so people can more easily set their equations into context. But that will be presented by Ankit later on, so I will not really go through that in detail. So yeah, now when the candy has gone all the way through, we're back to the candy. So when you took some, I don't know how randomly you chose what to take. Some of them were sour. Other ones were salty, some were licorice, some were sugar. So we have all sorts of candy in Sweden. But they are nicely structured. This is from my grocery store back home in Linköping. When I enter, there is a wall full of this, the first thing I see. But this is not that wall. This is at the exit, because there's another one there. And I only eat candy basically when I'm cycling, so I don't buy too much. But anyways, you have all these things, and some might love the sort of, let's say, sugar-loaded candies that we have here. Someone will love the sour candies that we have here, and then we have some licorice over there, and so on, or a combination of them. What we're working on 12.1 is sort of like that. We have a bunch of different things that, in a sense, not always, you won't always see the fit with all of them, but you can pick between those things for your perfect package. First thing, synchronous. So we're adding a library for modeling synchronous systems, basically systems that are clocked. Typically, SystemModeler works with continuous systems. I throw a stone and want to see how that travels from point A to point B. But every now and then, for instance, if you have a control system that might be have some sort of clocked system in it and so on, and then you want to be able to model that too. So we are introducing support for that, and I will show that with an example here. So let's go here. An opening in the presenter mode of SystemModeler that has been changed for this release, so we can focus only on the model. What we see here is a mixing tank over here, and we want to control the level of the mixing tank. So we have the same mixing tank model here. It's the very same. It's a continuous system in both cases. But we can see that it's in sort of a box here. That box is a box that inverts the model. So it automatically makes the inverse of the same model. Then inside this red box, you can see here on the left, there's a sample unit that will sort of is sampled by a clock. Could be sort of any, it can be frequent, you can clock like in any combination you would like. And we have another sampler here, and here is something called a hold unit. So everything in that red region is within this sort of sampled region. That means that everything in here will be treated as if it's discrete rather than continuous, even though the models are actually continuous. So let's simulate that. So I simulate this, and I can see an output here. Let me zoom in like that. Just for a bit. We see that the two different signals, we can zoom in a bit more actually to get it even clearer. So the upper one there has some dots on it and dashes. That's the synchronous signal. So it only has values actually at the dots, while this one is a continuous signal, so it's represented differently. And all this is taken care of automatically. As soon as you add your sample and hold units, this will work. In this case, we have on purpose made a sort of a bad controller in order to make it easy to distinguish between the two systems. In the presentation later on, if you download it, there are more step-by-step details on each of the examples with more descriptions, so you can run through and understand a bit more. So this is the part of Synchronous then. Create system model. Are people using anyone using create system model here? Moment. Yeah, a few here. So yeah. So then I'll take a bit of time here. So what we have focused on for create system model now is mostly on making it complete when it comes to state space models. So now we can handle systems with delays. We can handle affine state space models and nonlinear state space models, which we could not do before. So if we take let's take the affine state space model as an example. So this is taken from the Mathematica documentation, actually the example in itself. So you might have seen this. We're not going to go through the sort of Mathematica part of it. But we're basically making a model in Mathematica here, and we can plot the result. So this is pure Wolfram language code, right, to get this sort of result here. But suppose now that you want to use this in the larger system, so you want to use it within SystemModeler, how do you do that? Well, then you'll use the create system model, and it says I will use pen here, which is up there. It should be, if I haven't changed name, it should be. I'm changing things. Yeah, so it's this affine state space model that we want to bring into SystemModeler, and we will give it this name here. Create system model pendulum, like that. So now we're creating that model, and if I would go over to SystemModeler, I can find it there, or I can do SystemModeler, get the text representation of it here, so we get sort of, we open here, and we get the Modelica code that was generated. So this is the SystemModeler representation of the same model. This means that this can now be used drag and drop as anything else within SystemModeler to build a larger system. Good. User interface has been a lot of things in user interface. One of my favorite things was sort of ready 2 days before I left Sweden. So means I lost track of time, but 4 or 5 days ago. And that's a documentation generator. So many times you develop a model or a library, and you want to have some documentation online for others to read it, right? You want to publish that. But in the models themselves, if we look at a model like this one, let's go and change to the modeler view. So in a model, typically, you do things like this. We see has no documentation, but you might go in and say, start write something, some documentation for it, right? And typically, this is what you do. You add pictures and so on, and to make this look nice, okay? So this is then built in the, you have spent this effort to make your library well documented, but how do you show this to others who don't have the library or don't have the software? Well, now you can easily right-click on something like my new in SystemModeler library here. I'll right-click there, and I say export as HTML. So let's do that. Then it's asked me if which things do I want to link. So this is my presentation for today, and I could say, okay, I want to link to Modelica files if I generated documentation for that. I want to link to Modelica Synchronous, for instance, which we are using. So let's say that I add Modelica Synchronous and add links to that. So I click OK. And now it starts to generate my documentation, generate those pages, and I can click this one here to get my web page. So this is a complete web page now with the documentation. So this is Chrome, which is my go-to browser. And it has all the documentation that I have written in my package. So for instance, if I go in here to new in 12x, click there, we get back to the Candy, which was the picture I had for information, and I see which package it contains. So I just presented Synchronous. We can go in and see there, Synchronous. What did I have as an example there? Well, I had just one example, automatic discretization. I can go in there, see the full documentation for it. I get which parameters it has. And I can also see which components it uses, like this. So I can see that this, and this is automatically part of the components, and this is automatically just sort of populated for you. You don't have to do anything, it just happens. So it has a gain, for instance, that's come from Modelica blocks, math gain, and it has a hold component here. This one is linked, this one not, because when I clicked here, I said, which things do I want to have linked? So I said, okay, let's link the things that goes to Modelica Synchronous. So then I can actually click on hold, and it takes me to that page from Modelica Synchronous, and I can understand more about how that works. pretty neat, right? This is not, well, it's local on my machine right now, but it could be, it's just, it doesn't need SystemModeler, it's just HTML pages. So it's saved here on my desktop. So these are the HTML files. So you just copy them wherever you want on a server where you want to have it on your. I have generated that too, and you can generate that for yourself, and then so you can generate for any library you have, for the Modelica standard library, for College Thermal, or for anything, and just push it and publish it wherever you like. Nice, right? Good. And there are a bunch of other things, like here's a short list of things included in Model Center. We won't go through that. Instead, we'll do a debugging example. Now I'm really tight on time. OK. I will do the beginning of this example. So many times when you're developing new models, you do that in the text mode, in this mode here. So let's do this. And it hasn't always been that easy to understand when you make a mistake, what kind of mistake have you actually done. So let's do some mistakes here. I have started with a model here. And I'll check the model. Let's do this so you can actually see what I'm doing. There you go. Right? So then it says, new instance of the resistor has, this one here has an unknown identifier V. It doesn't recognize V, meaning I haven't declared V. So I have to do that. So I can do that here, and I can immediately, right now we're only showing a single error. That will be multiple errors later on. And it has actually, I can really immediately see that I has the same problem. So I could do this, add them. So now I declared both those, and I'll check again. And it tells me, OK, this works, but it has two variables and one equation, which means that it's unbalanced. We'll need as many variables as equations to get it to simulate. So that could be, for instance, adding a simple equation that would be a battery, let's say, constant voltage. And now we would have something that works. However, it wouldn't work to plug and play into another system because it doesn't have any connections to it. So you can't use it within another system. So you might want to do that. And so let's do that. Let's say I want to then use this. I go to electrical, analog, interfaces, and find an interface I want to use. For instance, let's use the one port. So I do this. I say extends one port. Bad at typing, so I prefer drag and drop. And then I check this. And suddenly it says element V is duplicated, but it's, and so on. So and let me click on what, then it tells me, OK, so we have a V here. Yeah, that was the one that I declared, right? But we also have one here in the example that I inherited from. And then it's up to me to remove one of those or make them equal, because I'm actually allowed to have it twice as long as they are identical. And this example, and that's included in the download presentation, shows step by step until we get a fully functional model. So it's a very good way to get exactly where you should fix and what you should fix when making errors. Fluid, I know there's a bunch here interested in fluid. I will only sort of show quickly a model here and invite people to come downstairs and discuss it further for details. But basically, we added a library. We're adding a library. This is not sure it will make 12.1. It's sort of right there to make it or not make it, depending on when 12.1 will come. But it makes it possible to deal with multi-phase flows. In this case, we have a drum boiler, and let's see, where are you? I talked with, let's see. There you are, yeah. So if you want to understand what this, I showed this to James, yeah, yesterday, and he immediately could explain what this was for me. It's not my area, but and that was the first time you saw SystemModeler, right? And I think that's sort of the beauty of it, that you can understand the model. If it's your discipline, you can understand it the first time you see it. Well, I sort of can fake, but now when he's here, I won't try to fake it. Two things before I'm done. Cloud. We're working on cloud support. It's the same issue that and now it's running on the cloud. I'm not running it here because I haven't been able to set it up on my computer. So this is a web browser. It's the Colles Thermal Lab that Ankit will show soon, running there. The big thing is the sandboxing, as we handle compiled C code, and the user can sort of compile anything they want, you need to make it safe so they don't harm the systems with their models. So that's what we're working on, and might make 12.1 or not. It's sort of 50-50, just as fluid. And as you can see, then runs just as it would have been on the desktop. Last thing, in a very sort of full-speed presentation, machine learning. Yet again, I won't go through all the details of it. But so the Wolfram language, as you know, has a lot of support for machine learning. It's very strong there. In many cases, you might want to combine this machine learning algorithm with a system model to get sort of something more complete. For instance, you want to have a machine learning algorithm as a controller. So this basically shows how. Let's do a couple of the steps. He threatened to kick me out, but here, Candy. Yeah. Good. So just do the first step here. So we have, I make some random input here that I will use. And then I have a system in SystemModeler, this one here, where I say, run this SystemModeler simulate using this input. Okay, so I simulate it with the input, and then I get some output, right? So I get the input and output. And then this continues, like, and we use here SystemModeler. Then we organize the data that we got from the output here. We set up a neural network. Then we train the network just as we would have done otherwise in the Wolfram language, nothing special, only that I have sort of hidden all the code to set it up. And it's not because I don't understand how the machine learning networks work. It's just so you don't have to see everything. Then this is what will be added. Create system model, perhaps a little bit bigger. I say, give it a name, mynet, and use this network that we created as the name. Now that, as I didn't run it, I will do this instead. I'll prepare it, and I'll show that as the last thing. We go here, modeler, go down to my example package, new in SystemModeler, machine learning, examples, and let's take this one with the cosine. So we have, this is our system in SystemModeler, the normal system. Then we make some time delay signals. We use these time delay signals to sort of forecast how we would expect the system to behave, which is on the right-hand side. This is our network that we developed in the Wolfram language. So we use this as a drag and drop thing. And then we can see how well does this network manage to predict my output. And we can see it here. That's sort of actually pretty good at doing that. And if I want to see things just as a final thing of user interface stuff, I can, for instance, drag here, put two markers, and I will get a bunch of measurements. For instance, what's the frequency, sort of what's the time between these two, what's the frequency, what's the maximum minimum value, and so on. So I get some more information. And there I got stop. Thank you very much.